IoT and embedded systems, a microcontroller often needs to interface with multiple switches, sensors, display devices, and so on. If we try to write the control logic using multiple if-else statements, the code becomes messy and difficult to maintain. This is where the switch case statement is useful. In this explanation, I'll show you how to write efficient and clean code using switch case in embedded C. Now let's understand the structure of a switch case statement. First we write the keyword switch followed by the variable name or expression that we want to evaluate. Then we write the cases, for example case 1, the statements that should execute if the variable matches value 1. Case 2, statements that should execute if the variable matches value 2. After each case we must include a break statement, otherwise execution will fall through to the next case. Finally, we add a default case which executes when none of the specified cases match. In our example, we used constant 1 and 2, but the case values can be 3, 4 or any other valid constant depending on the variable or expression. Now let's take an example in the context of embedded systems. So here we are using Atmega 16 microcontroller, but the concept however applies to other microcontrollers and development boards as well. So we have two switches connected to PB0 and PB1 and two LEDs connected to PA0 and PA1. Here PB and PA are ports of the microcontroller, and PB0 and PB1 are pin number 0 and pin number 1 of port B. PA0 and PA1 are pin number 0 and pin number 1 of port A. The LEDs 1 is connected to PA0, LED 2 is connected to PA1, and the switch S1 is connected to PB1 and S2 is connected to PB0. Now you also need to understand the switch logic levels. So when a switch is open, the pin reads logic 1 because the pin is connected to a pull-up resistor. When a switch is closed, the pin is connected to ground, so it reads logic 0. The task of, now let's understand the task. So we want to implement the following. So we want to do the following operation. If S1 is closed, S2 is open, turn on the LED 1. If S2 is closed and S1 is open, turn on LED 2. If both S1 and S2 are closed, turn on both the LEDs. Otherwise, turn off both the LEDs. Okay, now we have to write a program to implement this task. So first we have to include the header file specific to the Atmega 16 microcontroller. Since the switches are connected to PB0 and PB1, we have to configure these pins in the input mode. And similarly, the LEDs are connected to PA0 and PA1. So these two pins have to be configured in the output. So to configure a port pin in the input mode, we have to reset the bit in the direction control register corresponding to the port pin. So here we have to reset the bit number 0 and bit number 1 of DDRB register. Similarly, to configure port pin in the output mode, we have to set the bit in the direction control register corresponding to the port pin. So to configure PA0 and PA1, we have to set the bit number 0 and bit number 1 of the DDRA register. In addition to this configuration, and P1 in the input mode or PA0 and P1 in the output mode, we also don't want to change rest of the port pin configurations. So for that we have to do AND operation for port B and OR operation for port A. Okay, now let's understand the main logic, how we can read the switch positions. The logic level of the switches have to read. So the logic level of the switches can be read from pin B data register. Now we need to read the pin number 0 and PB0 and PB1. So the logic level corresponding to PB0 and PB1 will reflect in the bit number 0 and bit number 1 of the pin B data register. So for that we have to do an AND operation, bitwise AND operation between the content of pin B and a number 0x03. And the result is stored in the variable A. So the value of A depends on the switch position. So now let's understand the case 1. So the case 1, S1 is closed, so the PB1 will be 0 and S2 is open, so PB0 will be 1. So the value of A will be 1, so the case 1 will be true for this condition. So for that we have to turn on LED 1 and turn off LED 2. Okay, now we have to turn on LED 1 and turn off LED 2. So for that we have port A data register. So in the data register we have to write 1 and 0 corresponding to LED 1 and LED 2 respectively. As the LED 1 is connected to PA naught, so we have to set this bit in the port A data register, and LED 2 is connected to PA1, so we have to reset the bit number 1 of the port A data register. Now for the case 2, the S2 is closed, so PB0 will be 0 and S1 is open, so PB1 is equal to 1. So if we do AND operation of the pin B and 0x03, the A will be 2. Now for that we have to write a logic to turn on the LED 2. So similarly we can use the port A data register, and we have to set the bit number 1 of port A data register, and we have to clear the bit number 0 of port A data register. And in this operation we are not changing the configuration, or we are not changing the logic level of rest of the pins. So that's why we are doing OR and AND operation of for the turning on and turning off the LEDs.